All right, so now we're going to do one of these that is a definite integral instead of indefinite integral. And you'll see it basically just goes the same way. And it's just a matter of like at what point do you do the evaluation and what parts have to be evaluated. So here's the integral. It looks pretty weird. So one thing to remember is you can rewrite things like this. When they like to put the dx up in the denominator, it really belongs up to the side. But yeah, everybody's going to put it in the denominator because it's cool that way. All right, so I'm going to break this down a little bit, and I'm going to pull the 1 over x squared out and have the ln x and then the dx, so then I can sort of see the parts a little bit more clearly. I can see that I have ln x, which I'm typically going to pick for my u, and I have 1 over x squared is something that I don't mind integrating, so I'm going to call that dv. So I'm going to have u equals ln x, du equals 1 over x dx. I need v and dv. So I'm saying that the dv is 1 over x squared dx, which is really the same as x to the negative 2 dx. So maybe it'll help me to write like that, x to the negative 2 dx. So that means that my v, as I do the antiderivative of that, and I'm going to have negative x to the negative 1 over negative 1. It's just x to the negative 1 over negative 1, right? X to the negative 1 over negative 1. So that equals negative 1 over x. All right, so there's my chart, and then I'm going to say that this integral is equal to, it's going to be the uv minus the integral of v du. So let's see what I get for that. So for my uv, I'm going to have ln of x times negative 1 over x. So ln x times negative 1 over x. All right, but so here's the deal about evaluation, because it's a definite integral. The uv part gets evaluated separately. So that's just 1 to e, and I just evaluate it. That's the whole deal. You can stop now. The rest of it is pretty straightforward. All right, so because then we're going to have integral 1 to e of v du, so that's negative 1 over x times 1 over x dx. Don't lose the dx's on the integrals. So I decided that I'm going to hold off on evaluating this and evaluate all of the parts at the same time. You could, of course, evaluate that right away, and we could put the negative 1 over x in the front, which would probably be nicer. Let's pull out the negative and make this plus, and we'll do integral 1 to e. The 1 over x's is going to be 1 over x squared, so let's go ahead and right away write x to the negative 2. All right, and then, yeah, I was going to do this before. Let's put the negative 1 over x in front. It's just a little bit cleaner writing. Doesn't matter, but should do that. And then the antiderivative of x to the negative 2, I'm ready to do this antiderivative. So it's going to be x to the negative 1 over negative 1. Of course, if you want to write negative 1 over x right away, you're welcome to do that. But it gets the evaluation symbols now, right? So as you're working on your own, follow this example and make sure you're writing things correctly. So a lot of people sort of get to the end and sort of have the right answer, but there's pieces all over. Don't do that. Have I mentioned that? Don't do that. Keep your lines complete, correct, and awesome. Keep your lines awesome. All right, so I'm going to rewrite this as negative 1 over x ln x 1 to e. I'm still not evaluating that. I'm going to pull out the negative 1 here just to make it easier, and then my x to the negative 1 is just 1 over x. I have 1 to e. Now I'm going to evaluate them all. All right, you could have evaluated this right up here. It's fine. You can do that. That's not a problem. You can also take a shortcut how you write these things. I'm going to go ahead and plug in everything. I'm going to plug in my e. I get negative 1 over e ln e. I'm doing that even though I know ln of e is 1. I know these things are going to simplify, but just to show you where everything is coming from. So this is going to be negative 1 over 1 ln of 1, right? If you know your logs pretty well, just don't write that because you already know it's going to be 0. You're welcome to do that. And then I'm going to plug in my e, so I have 1 over e, and then I have 1 over 1, so it's going to be minus. I'm going to go ahead and write 1 over 1, even though we all know that's 1. All right, now I'm going to say, okay, I know ln of e is 1, so this is just negative 1 over e. I know that ln of 1 is 0, so that term goes away. And then I have minus 1 over e here, and I have, distributing the negative, I have plus 1. So this equals 1 minus 2 over e. Pretty cool. There you go. That is a complete definite integral using integration by parts. Make your work look nice. I'm going to do one more example. Yeah, just one more, and then turn you loose on it.